Algebra 1 PLP. Here's a study guide to help get you ready for Spiral Exam 3. So the Spiral Exam is like the other two that you've taken. It covers everything that you've studied so far in Algebra 1. It's a cumulative test. So for each of these, you need to go over all the concepts you've learned so far and look over the problems. So on this study guide, we're going to cover 10 key concepts and skills that will be on the exam. It's not everything that's on the exam, but it's the newest information from Units 6 and 7 that you've covered the past few months. Also, you want to look at your study guides from the Spiral Exams 1 and 2, your notes, and the unit study guides. That will help you get ready for the test. The test is multiple choice. It's on Math Excel. So here we go on our review of concepts of Unit 6 and 7. So the first question covers being able to solve a linear system of equations by graphing. So if you look at question A, you can see two lines graphed. And remember that a solution to a system is a point of intersection. So we are looking for, on graph A, a point of intersection. So I'm going to circle that point, and to name it we need to pick out the x and the y coordinate. So from the origin I go over -1 to get above the point, and then I move down 2. So the solution to the first system is -1, 2. Now the next system, we have 2 points, there's 2 lines graphed again. I'm going to circle that point of intersection. So from the origin, I move over 2 to get below, so that's in the negative direction, and then I move up 1, 2, 3, 4. So that's a positive y value of 4. So the solution to my first system is the point -1, -2, and to my second system is -2, 4. The next concept that you need to know is to be able to solve a linear system of equations by substitution. So this comes from concept 32. So when you're substituting, you want to get one of the equations solved for one variable. So you can see in the first equation it is solved for y. So what we're going to do is take that value, what y equals, and we're going to substitute it in to the second equation for y. So my second equation is x minus the value of y. I'm going to open a parentheses. That is 3x plus 5. I'm going to close it, and that equals 1. Then I just go ahead and solve by distributing that -1, combining my like terms, and solving for x. So the x value of my solution is -3. Now my second substitution is that I need to take that value for x and plug it back into one of my equations, just one of the originals. It's going to be easiest to put it in that first equation. So y equals 3 times -3 plus 5. So y equals -9 plus 5, or -4. So I've got the solution -3, -4. Another thing you need to be able to do for this spiral exam is to solve a linear system using elimination. And remember, that's when we line up our variables and then do any adjusting that we need to do in order to either eliminate our x's or our y variables when we add those equations together. So I look at my two equations, I realize that they are lined up. The y variables, the x variables, and my constants. I look and I see that my x variables are opposites. And so I can go ahead and add those equations. And when I do that, my x variables will eliminate. So 3y plus 5y is 8y. 6 plus 10 is 16. Divide both sides by 8. So y equals 2. Then I'm going to choose either one of my original equations, and I am just choosing the first one. and I'm going to substitute. We do a little bit of substituting when we are using elimination. So 3 times 2 plus 2x equals 6. So 6 plus 2x equals 6. 2x equals 0, so x equals 0. So the solution to this system, or where these two lines cross, is the point 0, 2. Now we're still talking about systems, but now we have moved to systems of linear inequalities. This is concept 34. And so this is where we graph these inequality lines and then shade, and the double shaded area is our solution. So I'm going to start by drawing an x and y axis, and let's label that. And then let's label a scale. One number on your axis is enough to show the scale. So I'm going to start with my first inequality. I'll be graphing that in blue. So I pick out my slope, which is 3, and my y-intercept, which is -1. So my first point will go at -1, and then I will go up 3 and over 1. I'm going to do that a couple times. Now I look at my inequality and I have a less than mark. So it's not going to be equal to, I'll try that again. So I am going to create a dashed line to show that this graph is not going to be equal to. And then I want to show everything that is less than, so I am going to shade below. So my second inequality, I'm going to graph in red. So my slope is -2, and my b value is +2. So I'll put a point at 2, and then down 2 and over 1. And I'll do that a few times. Now this does have an equal to mark, so this is going to be a solid line. And then we want to show everything that's greater than. So kind of the little rule of thumb is to shade above. Whoop. Let's switch my colors. There we go. So our solution set is the double shaded area. So our solution area is just in there. Now look at the second system. We've got x is greater than 5, and x plus y is less than or equal to -1. So let's start by drawing our xy axis, labeling a scale. I'm going to graph the first line in blue. So I go to where x is 5, and then I just dash a vertical line right through there. I want to show everything that's greater than 5. So I'm going to shade to the right, positive. Now my second line is not in slope-intercept form. So the first thing I'm going to do is subtract my x over. So I get -x minus. My slope is -1. My y-intercept is also -1. So first point goes at -1. And then I'm going to go down 1 and over 1. And do this a few times. I do have an equal to mark. So that'll be a solid line. And then I need to graph everything that is less than. So that's going to be underneath here. So at least from what we can see of the solution region, it's not a big area. Now if we could continue our graph, then it would continue to grow. But all the points that are contained within this double shaded area are a solution to this linear inequality system. Another concept that you want to review are properties of exponents and how to simplify exponent expressions. So from the notes in concepts 35 and 36, I have brought that table of the properties out. So you can quickly look through when we multiply bases, same bases together, we can add the exponents. And you can see an example, 5 to the third times 5 to the seventh. Bases are the same, so we get to add the exponents. When you raise a power to a power, you multiply those exponents. So m to the fourth raised to the second power, you can multiply, which is m to the eighth. When you have a power to a power outside the parentheses, you raise both of those terms to that power. When you're dividing same bases with different exponents, you can subtract. And then finally, a zero exponent. Anything raised to the zero power except 0 will be 1. So if you look at problem A, we need to simplify this. So I'm just going to start and simplify numerator and denominator and then look between the two. So exponents first. So I'm going to raise each of these terms to the second power. This is x to the first power. When I raise a power to a power, I multiply my powers. So 1 times 2 is 2. 2 times 2 is 4. My z is also to the first power. 1 times 2 is 2. And then I have 21 x to the fourth, y, z to the second. Now I'm going to take a few more steps to simplify. I'm going to simplify my integers just like a fraction. So I'll have 1/7. So up top I can draw out my parentheses. So x squared y to the fourth z squared over 7 x to the fourth y z squared. So I'm going to take this one at a time. I'm going to start with my x variables. I take the bigger exponent minus the smaller. So 4 minus 2. And then wherever that bigger exponent started, that's where the term ends. So I have simplified those. Now I'll look at my y's. So I have y to the fourth power over y to the first power. Since we're dividing same bases with different powers, I can subtract my powers. Bigger minus smaller is 3, and my bigger power started in the numerator, so that's where my y's will end up. Now finally, anything divided by itself is 1. So z squared divided by z squared is simply 1, and I don't need to write that. So this is my simplified expression of that problem A. Now with problem B, I can start by simplifying my numbers. So I can divide 20 and 15 both by 5. So I get 4 and 3. I'm dividing so I can subtract my exponents. So I'll take the bigger one minus the smaller. I'll show you what I'm going to do here. 5 minus a negative 4. So I will get 4 over 3 times n to the 9th. Now the last problem is a figure it out. What's the value of x that would make the sentence true? So I look at the property that's happening. Some number minus 5 will equal -3. So I could even write an equation. I can just think it through too, but let's write an equation. Some number minus 5 will equal -3. So I can just add 5 to both sides and figure out that that top exponent should be 2. Another concept to review is solving exponential equations using common bases. This is concept 38. So if you look at this equation, notice that your x's, what you're trying to solve for, is part of the exponent. So we're going to look at 3 and 27 and think about a common base. Well, 3 I can't do much with, but 27 I think about 3 and realize if I raise it to the third power, then that would equal 27. So I'm just going to bring my first term, and then 3 to the third power, but it's also raised to the x, because that's what it was originally. When you raise a power to a power, you simply multiply. When your bases are the same, you can just disregard your bases and set those exponents equal to each other. Now we'll just solve for x. So I'll subtract my 2x. -1 equals x. So that's my solution to x. Now in number 7, let's look at our bases, 5 and 25. So 5 can't be written as the power of any other base, but 25, I could rewrite that in terms of 5. So I'll have 5 to the 3x minus 8 power, and then I can rewrite 25 as 5 squared. But then I have to raise it to the 2x power. So 5 to the 3x minus 8 power equals, when I raise a power to a power, I multiply. When my bases are the same, I can disregard them and set my exponents equal to each other. Then I can solve for x, so I'll subtract my 3x over. -8 equals x. This is an earlier concept that I wanted to review with you to help you with some problems on the Spiral Exam 3. So it's from concept 19, and it's arithmetic and geometric sequences. So given the sequence, tell if it's arithmetic or geometric and determine the 9th term in the sequence. So remember that arithmetic is a linear pattern where geometric is a multiplier. So with a linear pattern, we're going to look for values that are added or subtracted. So right here, I can see that I'm adding a difference of 2 every time. This is my first term, 4. So I can plug in 9 for n, and that will help me find the 9th term. So that's what this means. We are finding the 9th term. So 4 plus 2 times 9 minus 1, or 4 plus 2 times 8. So the 9th term in this sequence is 20. And that is an arithmetic sequence because it follows a linear pattern. 2 is being added each time. Now in number 9, you can tell this is a different setup. So our beginning term is 18, and then it's being multiplied by a half. So when you have a multiplier, you've got a geometric sequence. So we can plug in 9, 18 times 1/2 to the 9 minus 1, or the 8th power. Now you can put that in your calculator as you see it, and it's going to give it to you as a decimal answer. And then if a problem starts out as a fraction, we want to end it as a fraction. So our decimal answer is this. And then I'm going to let my calculator help me look at that as a fraction. So as a fraction, it is 9 over 128. And this is a geometric sequence because of the multiplier. Another earlier concept to review is concept 15. So distinguishing between functions by looking at a table. So remember, we can look at differences. So let's see if this is a linear pattern. So I need to add 9. And here, I need to subtract 18 to get from 6 to negative 12. And here, I need to add 36. So that's clearly not a linear pattern. So let's see if it's quadratic. Let's look at second differences. So negative 18 minus 9, so I have to subtract 27. All right, so that is not linear and not quadratic. So perhaps this is exponential. Let's look and see if we have a multiplier. I'll do this in red. So to get from 3 to negative 3 to 6, I can multiply by negative 2. To get from, there it is, 6 to negative 12, I can multiply by negative 2 and multiply by negative 2. So because I have a multiplier, this is an exponential function. I should make note that I can examine my y values because my x values are increasing at an even rate. Now be sure to look over your notes and problems from each of the units to get ready for this test. Make a note on the last page of your handout of any of those concepts that you want to study. Then watch the final video in the playlist and answer the question below. And good luck on Spiral Exam number 3.